So we work on real world problems or applications. We're interested in the components of the vectors. So if I have this vector F, I have two components, W1 and W2. So we can look at the force of something pulling down a ramp due to gravity and the force against the ramp due to gravity. So this would be the one that's due to gravity, and this would be the one that's against the ramp. So they're orthogonal. See, there's a right angle here. And then what I know is that the total force is the sum of these two parts. And so I just have to know that this is, again, gravity and against the ramp. Okay, so I want to define projection and vector components. So if I have u and v and they're non-zero, and I can define u as w1 plus w2, and I know that w1 is parallel to v and w2 is orthogonal or perpendicular to v, then I know some other things. I know we call w1 is the projection of u onto v, and we write it as w1 equals the projection, and we do it's u onto v, so we write it like that. And then we know that w2 is u minus w1. And so this is the part that's orthogonal, and this is the part that is along v. So this is along v. This is a part of, this is the component of u along v, and this is the component of u perpendicular orthogonal to v. So I can find those two pieces. So I can find this projection using the dot product. There's a way to find it. So I have u and v again, non-zero. And then I know that the projection of u onto v, so the projection of, u onto v is the same as the dot product of u and v by its magnitude times v. So what this tells me is this is the unit vector v. So I'm going u dot the unit vector v, so I'm finding that, and then I want it to be in the same direction as v. So it's parallel. That's why I take this scalar here and I multiply it by the vector v.